All right, now we're gonna talk cycloalkanes. It's gonna be the exact same way we did the regular alkanes, except you have two new rules. Okay, so when the branches have more carbons than the ring is gonna be named as a substituent. Number the ring to give the substituents the lowest set of numbers and name them in alphabetical order. Okay, so let's start with this one right here. All right, so we're gonna we have a ring, and let's look at the longest continuous chain outside of the ring. So we have 1, 2. Okay, so that is an ethyl group. So how many carbons on the ring? 1, 2, 3, 4, 5. So we have a pentose ring. Or I don't want to say pentose ring, but we have a pentane, we have a cyclopentane ring. That's what we have. We have 5 carbons, and then we have a 2 carbon substituent with a substituent. Okay, so this is gonna be named as a cycloalkane. All right, so how are we gonna name it? So what is the substituent? We got ethyl. And then we have a 1-methyl. Okay, because it is 1 because it's hanging off the first carbon of the substituent. All right, so let's name it. So this is carbon 1 right here. Remember, you name the compound to give the substituents the lowest number. So this is gonna be carbon 1, and you can go 2, 3, 4, 5, or 2, 3, 4, 5. It doesn't matter in this sense. So we got 1, and then in parentheses you're gonna have 1-methyl ethyl cyclopentane. Easy, okay? Now let's look at this right here. All right, so we have a tri-substituted ring. So how many carbons are in the ring? 1, 2, 3, 4, 5, 6. So we got a cyclohexane. And let's look at the group. So we have a methyl here, 1, 2, and an ethyl here. All right, so now we have to number them. Number the ring to give the substituents the lowest set of numbers. Okay, so if we start here, we would have 1, 2, 3, 4. All right, so that's one way we can do it. If we started here, we would have 1, 2. Well, hold on, let me write that down. Let me record that. So we have 1, 2, 3, 4. So we would have 1, 2, 4 for our substituents. If we started here, we would have 1, 2, 3, 4, 5, 6. So we have 1, 3, 6. All right. If we started here, we would have 1, 2, 3, 4, 5, 6. So it'd be 1, 4, and 5. All right. If we started here and went this way, you gotta get it. You know, you gotta exhaust all possibilities. So you have 1, 2, 3, 4, 5. So it'd be 1, 2, and 5. If we started here and went this way, we would have 1, 2, 3, 4, 5, 6. So we have 1, 4, and 6. So when it says the lowest set of numbers, is going to be this right here. It's going to be this one, where you have one, or where you have 1, 2, 3, 4, 5, 6. Okay, that's gonna be how you orient your carbons on this ring, like that. All right. So now that we have our orientation, now let's name it. So we have a methyl, we have 2 methyls, and we have an ethyl. So what comes first? The ethyl, because it starts with an E. So we have a 2-ethyl. How many methyl groups we have? We have 2. So it's 2-ethyl, 1,4-dimethyl. Cyclohexane. All right. Easy. All right, so now let's look at this right here. Now we have a cycloalkane and a chain. So we have 1, 2, 3. Okay, so this is gonna be a cyclopropane. How long is the chain? 1, 2, 3, 4. So we actually have a chain that has more carbons than the ring. So this ring is gonna be named as a substituent group. So let's name it. Let's number the carbons first. So we got 1, 2, 3, 4. All right. So we have a 1 cyclopropyl. What if we went from the other side? We would have 1, 2, 3, 4. So this would be 4 cyclopropyl. Okay, so that violates the rules about giving the substituent with the lowest number, number 2. All right, rule number 2. So that violates rule number 2. So it's gonna be 1, 1, 2, 3, 4. All right. So this is going to be 1 cyclopropyl butane. All right. Easy. Don't make this harder than it is. All right. Remember, if you follow the rules, you will never go wrong.